All right, for 12.4, I'll take a look at 5 problems to help you out with the homework. The first 3 are just finding the limit as x or t or n or whatever variable they give you approaches infinity of a function. So just remembering how to find the horizontal asymptote basically for these first 3 functions. And then the last 2 I'll take a look at will be similar to the last couple that you have in the homework. One where they ask you to write the first 5 terms of the sequence and then find the limit of the sequence as it goes to infinity is what they're implying, if it exists. And then kind of the same for this thing. Simplify this function and then find the limit as it approaches infinity. Alright, so all you have to remember when you're looking at these first 3, when they ask you to find the limit as x approaches infinity, is you are looking for the horizontal asymptote. So you just have to remember your horizontal asymptote rules. For example, if the degree of the numerator, which is 1 here, and the degree of the denominator, which is also 1 here, are the same, you divide the leading coefficients. So for this one, it is simply negative 6/5. Now I know in the notes we wrote down a bunch of stuff like this. We would write down 1 over x minus 6 over x over 1 over x plus 5x over x, and we did the limit as x approaches infinity. But remember I said you didn't have to run through and do all that. This is the long way. Realistically, all you need to do is go straight from the equation to the answer, and there's no work to show for it. Alright, for number 2, find the limit as x approaches infinity of x squared over x. Again, you're looking at the degree of the numerator and the denominator. So the degree of the numerator is 2, the degree of the denominator is 1, the degree of the numerator is larger, which means we're dealing with some sort of slant asymptote, and so that means that our limit does not exist. Or you might see next year that we would say the limit is going off to infinity or negative infinity depending on the problem. For now, what we're going to do is we're just going to say it does not exist. Alright, and then the third one, or last one of these, finding the limit as x approaches infinity of 1 over 4x squared minus 5x over 2x plus 1. It's basically the exact same thing as these problems, you just do them separately. If you notice, you've got 2 things being added or subtracted. Find the limit of them separately and then add or subtract the limit. That was one of the identities we looked at. So I'm just going to find the limit as x approaches infinity of that function. Since the degree of the numerator is 0, because there's no x in there, or it's x to the 0 if you want to think of it that way, the degree of the denominator is 2. It's smaller. That means the limit of this is automatically 0. Minus the degree of the numerator is 1, degree of the denominator is 1. They're the same, so I divide the leading coefficients. So it's 0 minus 5 over 2, or it's just going to be negative 5 halves. And there is my limit. No matter how many of these things are being added, subtracted, you could always do that. Could you get a common denominator and combine them? Yes, but to me this would be much easier, just doing all these limits separately and then adding them together. Alright, so now we look at the last 2. You'll have one that looks kind of like this, and hopefully you remember what that symbol means. That means factorial. So for example, 3 factorial is 3 times 2 times 1. Or 6 factorial would be, start with that number 6 times 5 times 4 times 3 times 2 times all the way down to 1 is what the definition would be, and then you just multiply those numbers together. So when I see this and they ask me to find the first 5 terms, well, if I plugged a 1 in here, so if I tried to find a sub 1, plugging a 1 would give me 2 factorial divided by 1 factorial, and 2 factorial is just 2 times 1, so 2 divided by 1 factorial is just 1, so the first term is just 2. Looking for the second term, a sub 2, if I plug a 2 in here, I get 2 plus 1 or 3. 3 factorial is 3 times 2 times 1. Plug a 2 in the denominator, it's 2 times 1. These cancel, I end up with 3. Look for the third term, plug a 3 in here, I'm going to get 4 factorial, so 4 times 3 times 2 times 1. Divided by, plug a 3 in for n. 3 factorial is 3 times 2 times 1. And if you haven't noticed by now, there's definitely a pattern. Everything is going to cancel out except for that first term. So even without showing the work, I know the fourth term is going to be 5, the fifth term is going to be 6. There are the first 5 terms. And now in terms of finding the limit as n approaches infinity, or finding the limit if the sequence exists, all you really have to do is look at these numbers. Remember what we've said. If these numbers, if they're increasing by anything more than 1, that means that it's eventually going to be going to infinity or negative infinity. If it's increasing by more than negative 1, it needs to be, the pattern needs to be kind of multiplication, or a couple ways you can do this. Like I said, hey, look at this, I can see that it's increasing by 1, so it's not going to approach a specific number, so I know the limit does not exist. Or if you take this function and simplify it, n plus 1 factorial, if you do kind of the same idea that we did over here, here's the actual number. Then if I subtract 1, so say this is 3, subtract 1 I would get 2. I'll subtract 1 from that I would get n. Subtract 1 from that I would get n minus 1, n minus 2, and it would just keep kind of going forever. If I do the same thing for the denominator, I would start with n, subtract 1, and that keeps going forever. And you're going to notice that all of these things eventually cancel, and that's what you simplify down to. So now if you did your rules like we did for the ones back here, for this, the limit as n approaches infinity of this function, it's degree 1, degree 0, the numerator is larger, so I know that this is going to go off to infinity, or we would just say the limit does not exist because of the slant asymptote. So you have a couple ways that you can do it. You can either look at the sequence of numbers, or you can simplify the function and then just find the limit of this. Alright, and you'll have one that has a factorial like that. And then you'll have a couple that look like this, and this is kind of the, I mean, it's all important, but this problem is really important because it goes directly into what we're going to be doing in section 5, being able to simplify stuff like this. So in terms of the simplifying, let's go ahead and just distribute. So I would take the 3 over n and distribute to these two. This is all considered one term because it's being multiplied together, so just make sure that you're careful with that. So in terms of doing that, I have 3 times n over n. The n's would cancel and I would get 3, plus if I multiply these terms together I get 6 over n squared. And remember, I only can multiply this by one of those, so I've already done it to this, so leave this alone for right now. n plus 1 over 5. Alright, minus, I can say that that's 4 over n to the 4th. It's asking me to square what's inside this bracket here, and notice that it is all being multiplied and divided, which means that I can square all 3 of these things individually. So, that's going to give me n squared, n minus 2 squared, which I won't go ahead and multiply out just yet, and then 3 squared, or 9. Alright, so I've squared this part, I've distributed the 3 over n, and now I'm going to do a little bit more simplifying. And like when you're multiplying numbers together, I say try to simplify first if you can, and try to get in the habit of looking for the n's. Nothing I can do to this one, but this n, since they're being multiplied together, and I've got 2 n's technically, that n and one of these n's can cancel. And that should always happen when you've got these n terms in there. So kind of look for that. Like if you come over to this one, I've got n squared, I've got technically 4 n's here. 2 of them can cancel, I'm still left with n squared. Most likely that's all that will cancel. The other thing that possibly could cancel is these two numbers, or these two numbers. They don't for this one. But usually those are the only things that are going to cancel. So that's going to give me 3 plus, now I'm going to go ahead and multiply stuff out since I've got it simplified as far as I can. So distribute the 6, I'm going to get 6n plus 6 over 5n. Minus, I'm now going to FOIL that out. I'm going to keep the 4 in front for now. That's going to give me n squared minus 4n plus 4 over 9n squared. And now we could easily multiply this all out. I think we know what that's eventually going to give us, so I'm not going to do it in this step. Now what I want to do is I want to get a common denominator. So if you look at your 3 denominators, you can say to yourself, well, that's factored completely, so I need a 1 in it, and that makes sense. 5 is factored already. It doesn't break down into any other prime numbers. It's already prime. It's 5 and n, so I need a 5 and I need an n. 9 breaks down to 2 3's. I don't have them, so I need to have 2 3's in my least common denominator. N squared is 2 n's. I've already got 1. I would need to tack on another one. So my least common denominator, if I multiply it all together, is 45n squared. So I want all my denominators to look like that. So the first one I'm going to have to multiply by 45n squared over 45n squared. The second one has 5n in it. It already has this, so I just need to tack that onto it. So I'm going to multiply both numerator and denominator by 9n. And then the last one has that in it. It's just missing this, so I'll multiply both numerator and denominator by 5n. Whoops. Sorry, I don't need the n. It actually has both of the n's and the 9. I just need the 5. Alright, and so I'm going to ignore my denominator since I know the denominator is going to be 45n squared. Just going to look at the numerator. So if I multiply 45 times 3, I know that's going to give me 135n squared, plus distribute here, that's going to give me 54n squared plus 54n. And then just think your way through it. You can either distribute the 4 if you haven't, or basically you're looking at negative 20 times all of these. So that's going to give you negative 20 n squared. Pay attention to signs. It's negative 20, negative 4, so positive 80 n, and then negative 80. And that's all over 45 n squared. Alright, and then combining like terms in the numerator, I've got a few n squareds in there. So I'll combine those together. Looks like that's going to give me 189 minus 20, or 169 n squared. Looking for the n terms, it looks like I've only got 2 of them, so add those together, and I should end up with 134, that looks like, n. And then I have my minus 80, and that's all over 45 n squared. So there's the answer, the first part of the answer in terms of taking this function and simplifying it. Now, if we did a good job at this step, simplifying the n's and whatever these two things have in common, I shouldn't have to worry about simplifying down here, as long as I got it all here. If I missed it, say this was 15, and I missed that they had the 3 in common, that means most likely I'm going to end up having to factor something out here, possibly. Just depends on kind of what happens. Or if you don't multiply by the least common denominator, you just multiply those two together and said it was 45n cubed, then you would have an extra n that you'd have to factor out. So try to do it with the least common denominator and with everything I'm showing you. Now the nice thing is once you've got this multiplied out, finding the limit as n approaches infinity means just look for the horizontal asymptote again. It's degree 2, so I divide the leading coefficients, and the limit as n approaches infinity would be 169 over 45. And again, it will be simplified already because we've already done our simplifying. But like I said, they're all important. You should know how to do all of them, but this one directly relates to what we're going to be doing over the next 2 days in section 12.5, so make sure that you're comfortable. If you just made a little mistake, not a big deal. Just make sure you have the general concept of it. All right, that is your homework help for 12.4. As always, feel free to come in and ask for help if you need to.